Welcome to the 8th and final module of the Securium Bootcamp. This module is about Audit Findings 201, where we will review 100 more findings from public audit reports of leading audit firms to get a sense for the kinds of issues reported during audits and their suggested fixes or recommendations. The severity range of these 100 findings spans a spectrum, but mainly focuses on medium to low severity, informational best practice guidelines, and some of the more application level business logic and software engineering aspects to get critical perspectives different from those in the previous module. To help level set expectations again, we will only be able to touch upon key aspects of these findings in this video presentation and hope to discuss any particular ones of interest in other forums of the bootcamp. The reason is that these findings require a lot of context from the deepest details of the protocol implementations, which we will certainly not have the time to do so for all 100 findings. This will need to be done by interested bootcamp participants in their own time by reviewing the audit reports and their corresponding protocol code bases to whatever depth possible. I would strongly encourage everyone to do so and at least read the audit reports covered here, if not the actual code bases of the audited projects themselves. For each finding, we will review the vulnerability category, its finding summary, and the proposed recommendation while relating some of these aspects to our learnings from the earlier modules. So with that, let's get started. 102 is a finding from Consensus Audit of Umbra related to access control and input validation, in which potential edge cases for hook receiver contracts were not documented or validated. For context, there were very few constraints on arguments to certain external calls in the Umbra contract. Anyone could force a call to a hook contract by transferring a small amount of tokens to an address that they controlled and withdrawing those tokens, passing the target address as the hook receiver. The recommendation was for the developers to document and validate such external function calls and untrusted parameters for potential edge cases. This is related to validation of function parameter arguments in 138 and 139 and broad aspects of access control specification in 148 and tests in 155 that we discussed in Security Pitfalls and Best Practices 201 module. 103 is another finding from Consensus Audit of Umbra related to specification and documentation of token behavior restrictions. For context, as with any protocol that interacts with arbitrary ERC20 tokens, it is important to clearly document which tokens are supported. This is best done by providing a specification for the behavior of the expected ERC20 tokens and only relaxing the specification after careful review of a particular class of tokens and their interactions with the protocol. The recommendation was that known deviations from normal ERC20 behavior should be explicitly noted as not supported by the Umbra protocol, such as 1. Deflationary or fee on transfer tokens. These are tokens in which the balance of the recipient of a transfer may not be increased by the amount of the transfer. There may also be some alternative mechanism by which balances are unexpectedly decreased. While these tokens can be successfully sent, the internal accounting of the Umbra contract will be out of sync with the balance as recorded in the token contract, resulting in loss of funds. 2. Inflationary tokens. The opposite of deflationary tokens, where the Umbra contract provided no mechanism for claiming positive balance adjustments for such tokens. And 3. Rebasing tokens. A combination of the above two cases of deflationary and inflationary tokens. Rebasing tokens are tokens in which an account's balance increases or decreases along with expansions or contractions in their supplies. The contract provided no mechanism to update its internal accounting in response to these unexpected balance adjustments, and funds may be lost as a result. This is related to token deflation via fees in 107, token inflation via interest in 108, guarded launch via asset types in 129, and broader aspects of token handling in 159, system specification and documentation in 136, 137, and accounting issues in 171 that we discussed in security pitfalls and best practices 201 module. 104 is a finding from consensus audit of DeFi Saver related to testing. The test suite was not complete and many of the tests failed to execute. For complicated systems such as DeFi Saver, which uses many different modules and interacts with different DeFi protocols, it is crucial to have a full test coverage that includes edge cases and failed scenarios, which is critical for safer development and future upgrades. As seen in some smart contract incidents, a complete test suite could have prevented issues that might be hard to find with manual reviews. So the recommendation was to add a full coverage test suite. This is related to the broad aspect of testing in 155 that we discussed in security pitfalls and best practices 201 module. 105 is another finding from consensus audit of DeFi Saver related to naming, documentation, and refactoring, where Kyber get rates code was unclear because function names did not reflect their true functionalities, and the code used some undocumented assumptions as well. The recommendation was to refactor the code to separate getting rate functionality with get sell rate and get buy rate, and also to explicitly document any assumptions in the code. This is related to broad aspects of system documentation in 137 and clarity in 188 that we discussed in security pitfalls and best practices 201 module. 106 is another finding from consensus audit of DeFi Saver related to error checking, where return value was not used for token utils withdraw tokens. For context, the return value of token utils withdraw tokens, which represented the actual amount of tokens that were transferred, was never used in the entire repository. This could cause discrepancy in the case where the requested transfer amount was UN256 max for some reason, in which case the amount actually transferred would be less than that requested and returned back, but never checked. The recommendation therefore was to check the return value to validate the withdrawal and use that in the event emitted. This is related to function return values in 142 and accounting issues in 171 that we discussed in security pitfalls and best practices 201 module. 107 is another finding from consensus audit of Umbra related to access control and logging, where there was missing access control for DeFi Saver logger.log, which was used as a logging aggregator within the system, but anyone could create logs. The recommendation was to add access control to all functions appropriately. This is related to broad aspects of access control implementation in 149 and auditing and logging in 173 that we discussed in security pitfalls and best practices 201 module. 108 is a finding from consensus audit of DAO5 related to documentation, where stale comments were present in the code base about storage slots. The recommendation was to remove such stale comments. This is related to comments in 154, redundant constructs in 157, and broad aspects of system documentation in 137 that we discussed in security pitfalls and best practices 201 module. 109 is a finding from consensus audit of mstable related to documentation, where there was a mismatch between what the code implemented and what the corresponding comment described. The recommendation was to update the code or the comment to be consistent. This is related to comments in 154 and broad aspects of system documentation in 137 and clarity issues in 188 that we discussed in security pitfalls and best practices 201 module. 110 is another finding from consensus audit of DAO5 related to unnecessary code or logic where there was an unnecessary call to DAO5 v1 factory formula function. For context, few DAO5 v1 pair functions used a private function which made a call to the factory to retrieve the immutable formula address set in the constructor. Instead, such calls could simply be replaced with that immutable value. The recommendation was therefore to remove such unnecessary calls and replace them with variable reads. This is related to broad aspects of redundant constructs in 157 and the principle of economy of mechanism in 197 that we discussed in security pitfalls and best practices 201 module. 111 is another finding from consensus audit of DAO5 related to testing, where increased testing of edge cases in complex mathematical operations could have identified at least one issue raised in the report. The recommendation was additional unit tests as well as fuzzing or property-based testing of curve-related operations for more validation of mathematical operations. This is related to the broad aspect of testing in 155 and numerical issues in 170 that we discussed in security pitfalls and best practices 201 module. 112 is a finding from consensus audit of the FADE protocol related to application logic where governor alpha proposals could be cancelled by the proposer even after they had been accepted and queued. For context, governor alpha allows proposals to be cancelled via cancel, but a proposer could cancel proposals in any of pending, active, cancelled, defeated, succeeded, queued, or expired states. The recommendation was to prevent proposals from being cancelled unless they were in pending or active states. This is related to function invocation timeliness and order in 143 and 145 and the broad aspects of ordering in 178 and business logic in 191 that we discussed in security pitfalls and best practices 201 module. 113 is a finding from consensus audit of ERLC related to access control and timing. For context, the KYC admin had the ability to freeze the funds of any user at any time by revoking the KYC member role. The trust requirements from users could be slightly decreased by implementing a delay on granting this ability to new addresses. Such a delay could also help protect the development team and the system itself in the event of a private key compromise of the KYC admin. The recommendation therefore was to use a Timelock controller as the KYC default admin of the ERLC contract. This is related to OpenZeppelin's Timelock controller library we discussed in 182 of Solidity 201 module and time delayed change of critical parameters in 163 along with broader aspects of access control changes in 153, timing in 177 and trust issues in 181 that we discussed in security pitfalls and best practices 201 module. 114 is a finding from consensus audit of 1inch related to documentation and testing where the source code hardly contained any inline documentation which made it hard to reason about functions and how they were supposed to be used. Additionally, the test coverage seemed to be limited, whereas especially for a public-facing exchange contract, system test coverage should have been extensive, covering all functions, especially those that could be directly accessed, including potentially security, relevant, and edge cases. This would have helped in detecting some of the findings raised with the report. So the recommendations were to consider adding NatSpec format compliant inline code documentation, describe functions, what they were used for, and who was supposed to interact with them, to document specific assumptions, and to increase test coverage. This is related to system documentation in 137, comments in 154, and broad aspects of testing in 155, and clarity issues in 188 that we discussed in security pitfalls and best practices 201 module. (115) is another finding from consensus audit of 1 inch related to configuration, where the compiler version pragma was unspecific in that it was floating or unlocked with caret 0.6.0. While that often makes sense for libraries to allow them to be included with multiple different versions of an application, it may be a security risk for the application implementation itself. A known vulnerable compiler version may accidentally be selected for deployment, or security tools might fall back to an older compiler version, ending up actually checking a different version from what is ultimately deployed in the blockchain. The recommendation was to avoid floating pragmas and pin a concrete compiler version, the latest without known security issues, in at least the top level deployed contracts to make it unambiguous as to which compiler version was being used. The suggested rule of thumb was that a flattened source unit should have at least one non-floating concrete Solidity compiler version pragma. This is related to unlocked pragma in number 2 of security pitfalls and best practices 101 module, and broader aspects of tests in 155 of security pitfalls and best practices 201 module. (116) is another finding from consensus audit of 1 inch related to denial of service, where hard-coded gas assumptions were pointed out as being problematic because gas economics in Ethereum have changed in the past and may change again, like with the recent EIP 1559, potentially rendering the contract system unusable in the future. The recommendation was to be aware of this potential limitation and be prepared by documenting and validating for situations where gas prices might change in a way that negatively affected the contracts. This is related to gas impact on denial of service in 42, 43, and 44 of security pitfalls and best practices 101 module, and broader aspects of gas issues in 182 of security pitfalls and best practices 201 module. 117 is another finding from consensus audit of 1 inch related to access control and input data validation, where it was a critical vulnerability in which anyone could steal all the funds that belong to the referral fee receiver. For context, any token or ETH that belonged to the referral fee receiver was at risk and could be drained by any user by providing a custom Uniswap pool contract that referenced existing token holdings, because none of the functions in the referral fee receiver verified that the user provided Uniswap pool address was actually deployed by the linked Uniswap factory. The recommendations were: 1. To enforce that the user provided Uniswap contract was actually deployed by the linked factory, because other contracts cannot be trusted. 2. Consider implementing token sorting and deduplication in the pool contract constructor as well. 3. Consider employing a re-entrancy guard to safeguard the contract from re-entry attacks. 4. Improve testing because the vulnerable functions were not covered at all. And 5. Improve documentation and provide a specification that outlined how this contract was supposed to be used. This is related to system specification and documentation in 136, 137, access control specification and implementation in 148, 149, and broader aspects of testing in 155, data validation issues in 169, and access control issues in 172 that we discussed in security pitfalls and best practices 201 module. 118 is another finding from consensus audit of 1 inch related to privileged roles and timing, where there could be unpredictable behavior for users due to admin front running or in general bad timing. For context, administrators of contracts could update or upgrade things in the system without warning, which could violate security goals of the system. Specifically, privileged roles could use front running to make malicious changes just ahead of incoming transactions, or purely accidental negative effects that could occur due to unfortunate timing of such changes. The recommendation was to give users advance notice of changes with a time lock, for example, by making all system parameter and upgrades to require 2 steps with a mandatory time window between them. The first step would broadcast to users that a particular change was coming, and the second step would then commit that change after a suitable waiting period. This would allow users that do not want to accept such change to exit, and others who are okay with those changes to continue engaging with the protocol. This is related to OpenZeppelin's Timelock controller library we discussed in 182 or Solidity 201 module, and 2-step change of privileged roles in 162, time delay change of critical parameters in 163, along with broader aspects of timing in 177, and trust issues in 181 that we discussed in Security Pitfalls and Best Practices 201 module. 190 is a finding from consensus audit of Growth DeFi related to specification and documentation, where the only documentation for Growth DeFi was a single README file, as well as some code comments. A system's design specification and supporting documentation should be as important as the system's implementation itself, because users rely on high-level documentation to understand the big picture of how a system works. Without spending time and effort to create such documentation, a user's only resource is the code itself, something the vast majority of users cannot understand. Security assessments depend on a complete technical specification to understand the specifics of how a system works. When a behavior is not specified or is specified incorrectly, security assessments must base their knowledge in assumptions, leading to less effective review. Also, maintaining and updating code relies on supporting documentation to know why the system is implemented in a specific way. If code maintainers cannot reference documentation, they must rely on memory or assistance to make high quality changes. The recommendation, therefore, was to improve system documentation and create a complete technical specification. This is related to broad aspects of system specification and documentation in 136 and 137, undefined behavior issues in 179, and clarity issues in 188 that we discussed in Security Pitfalls and Best Practices 201 module. 120 is another finding from consensus audit of Growth DeFi related to access control and least privilege mechanism, where system states, roles, and permissions were not sufficiently restrictive. Smart contract code should strive to be strict where it behaves predictably, is easier to maintain, and increases a system's ability to handle non-ideal conditions, whereas many of Growth DeFi states, roles, and permissions were loosely defined. The recommendation was to document and monitor the use of administrative permissions, and also specify strict operational requirements for each contract as it pertains to roles and permissions. This is related to access control specification, implementation, and changes in 148, 149, and 153, and broader aspects of access control issues in 172, and principle of least privilege in 192 that we discussed in Security Pitfalls and Best Practices 201 module.